In this video, we'll be learning about the intermediate value theorem. It's a fairly basic theorem. I'm just going to explain it down here on this little graph. It's hard to see, so I'm going to trace what this graph is. Okay, so this graph is talking about the altitude of a plane. So here's your plane on the ground, it starts to take off, and then it keeps going, and eventually it reaches, just say, 1,000 meters in the air. So the IVT, intermediate value theorem, is going to say that, well, at some point, your plane, between going from 0 to 10,000, had to reach a height of 5,000. That's what this whole dotted line is. Okay, so that's all the IVT says, is that if you have something that's continuous, like altitude of a plane is a continuous function, between the two endpoints, it must have touched every single value, 1, 2, 3, 4, 5, all the way through, all the way up to 10,000. Okay? So, intermediate value theorem. This is something else where this is a 3, you need to show all 3 steps. If it ever asks for the intermediate value theorem, or if you need to show that it equals a value at some point. So you need to show all these steps. F is continuous on a closed interval. What's nice about this is we're not asked to show if it's continuous specifically, so we can just do this real quick in our heads and just figure out, okay, the function is continuous. The endpoints cannot be equal, and that there must be a value k between f of a and f of b. So there must be a k value between those, and then there exists a number c that's between a and b, for which f of c is equal to k. So k is the height. So there's a height between my two endpoints in which there's an x value can occur at that height. Okay, so that's all it's saying. And if you look again at the altitude of the plane, all right, it's continuous, so it checks off 1. The endpoints are different, checks off 2, and then it touches 5,000 between the 2 points. That checks off 3. So then the conclusion is there's number C. It doesn't really say. I'm just going to write down a C right here. There's a number C right here, which is between A and B, for which, you know, this is what the FC equals K part says right there. It hits that point. Like if you have a graph like this, by the way, this is the greatest integer function graph. It just tells you that all your answers are always going to be integers in this graph. It's not continuous. There's a bunch of jump discontinuities, so number 1 fails. So this you cannot use IVT for. Okay? Let's get to a problem. So it says, show whether the conditions of the intermediate value theorem hold for the given value of k. We're going to sketch the curve and the line y equals k, and if they do, find a number c such that f of c is equal to k. Alright, so I have my 3 conditions I have to meet. So here's my function right here. It's on this interval, and then the k value is right there. Okay. It does help to know what this looks like. So this is actually just a rational function that got shifted over to. So the function looks like this. So it's got a horizontal asymptote at 2. So the function looks something like this. So this is not continuous, this function, but look at my interval. It's between 3 and 5. So it's from here to here. And it is continuous in an interval. So it's important to state that for the first one, that it is continuous. The function is continuous on the interval. So the IVT can work. Second one, the heights at 3 cannot match the height at 5. So I'm going to do f of 3. By the way, if I plug in a 3 here, I'm going to get 1 over 3 minus 1, which is just 1, which is not equal f of 5. Because if I plug in a 5, I'm going to get 1/3. And then my k value, it wants 5/6. Well, is 5/6 between 1 and 1/3? Well, it is. So 5/6 is between f of 3 and f of 5. So now this works. So we can use the IVT. This is just asked to show the conditions, so we did. And there we go. So we just proved all the conditions. Now it does want to find a value c. So to find that c value, all you're going to do is go ahead and plug this 5/6 into here. So the function of the height will equal 5/6 at what c value? So then all you do from here is just you go ahead and solve. So you're going to get 5x minus 10 equals 6 by cross multiplying. You're going to get 5x equals 16. You're going to get x equals 16/5. Okay? You make sure this is in your domain here, or your given interval from 3 to 5. Alright, and if this value is in there, you have to check that it's in there. Sometimes it won't be, or sometimes you get multiple answers and you figure out which ones work. So this works, so this will graduate to a c value. And there we go. So just real quick recap. Given a function, given this interval, it has to equal some type of k value at 5/6. So if I were to draw that 5/6 would be somewhere along the lines of here. So it's between. So the endpoints are not equal because there's an endpoint, there's an endpoint. So 5/6 is in between that right there. Where does it touch at? Again, it's just a sketch. It equals 5/6 at this point C, which I'm saying is 16/5. It's not to scale on my picture, but this will work out here. And that concludes the IVT.